Welcome back. We continue in this lesson to look together at what different render passes are provided to us by cycles that can be used from the input node. We looked last time at the entries up to index material. Let's start today by looking at diffuse light. Diffuse light is itself composed of three different types of light. Direct light, so diffuse and direct, indirect light, and color. Let's look at the first one. Here we see a black and white image representing the amount of light that directly hits our objects. Indirect diffuse light, on the other hand, is that light that does not reach our objects directly, but comes from a bounce. Imagine individual light rays starting from the light source hitting an object, then bouncing off and going to indirectly hit the objects in our scene. In fact, we see that the background is practically black because it does not receive any bounce light. Instead, we see that the light hitting the floor contains within it the color of the material. Here in the foreground we have a green light because the material of the object is green. We also see it here on the second object, the middle one, which receives a green bounce light, while in the third object the bounce light is orange, and he in turn bounces a blue light instead. Diffuse color, on the other hand, is pure color, without shadows, without reflections, without the influence of light. In fact, we see this, which is a completely flat image. After diffuse light, we have glossy light. Again, we have glossy direct, that is of direct light, indirect, and color. Let's go and see. Glossy direct, similarly to what happens with diffuse direct, starts from the light source, hits our objects, and is bounced back based on the quality of the material that defines its reflectivity. In a nutshell, in this black and white image, we see the ability of the material we have set to reflect light in a direct manner, that is, all that light coming to hit the object directly. For example, we see this edge on the left of the first object because it is coming from a light source on the back and therefore directly hitting our subject. Glossy indirect is indirect light, so bounce light, so the front of the objects we see black because the light hits these objects and then bounces off, but we are instead seeing bounce light. In fact, in the second object we can see mirrored the first one, which is green. The third object sees the first, which is green, and the second. In short, we see everything that is reflected by our material. The floor also has a reflective ability, and in fact reflects the three colors of our objects. Finally, we have glossy color, which shows us the color of the reflected light. All of these images will be able to be used as overlapping layers, kind of like what happens in photo editing programs. They will be able to be exported individually, and then they can be used to create really point effects on each individual part of the image. We're going to look at the transmission group, which is transmission direct, indirect, and color. But in this case, you see all three of them black. So let's go to edit one of the materials and relaunch the rendering. Let's go to Layout, select the first object, and go apply a transmission value, for example, of 0.5. Let's now select the second object and set a value of 1 as transmission. Let us now try rendering again and see what the input node gives us for transmission values. While transmission direct continues to be a completely black image because we have no direct light passing through our objects, transmission indirect is a very interesting image. Here we see the first and second objects appear. The third one does not because it does not contain any transparency component. In the first one we had set a value of 0.5. In the second one we set a value of 1. In fact, you can see the difference very well. You will surely have noticed the graininess as well as in other images. This depends on the number of samples and the fact that these are images that are produced before the application of denoise. Let's go to transmission color, and we see an image very similar to diffuse color because precisely it is pure and simple color, no shadow, no transparency, no effect, pure and simple color. The third object we do not see because it does not have any transparency information. Here we are only seeing the color of the objects with a minimum of transparency. Before we go on, let's take a moment to look at the image again. Let's go back to glossy direct and, for example, glossy indirect. Let's go look at these images again. Let's see that there is grain. Let's see that there are reflected images, but are these images really there? Let's go look at the final image and let's look at it closely. As we can see here, you can see the white portions of the glossy very well. You can see the objects very well, and you can also see the reflected objects. Here at this point you can see the green vase that is reflected on the red one, and here, even though it is only just hinted at, you can see the first two objects that are reflected at this point. One thing that you don't notice, but there is everything about the reflected light on the floor, so the indirect light that we have seen has color. Sometimes the eye doesn't see a lot of details, but these are there, and the presence of these color gradients make the image much more believable. That is why it is preferable to use, for example, as an ambient light, an image rather than a monochromatic light, because an ambient image allows us to have a great wealth of direct and indirect light nuances going to the objects in our scene. Then we have volume direct and volume indirect, so image information with volumetric materials. In this case, in our scene, we don't have any, but we can go and add one and see what happens. We insert in the scene a simple parallel pipe starting from a cube to which we are going to apply a volumetric material. In this example, I also applied a gradient to simulate a kind of light ray. So we run the rendering, and this is the result. As an output from the volume direct channel, we then have an image that is always in black and white, which reports to us the intensity of the volumetric direct light. Similarly, we could have the same kind of image for indirect light. As for the information instead inherent, the emission lights, let's now insert a simple cube to which we're going to apply a new material that we're going to call emission, and to which we're going to give, for example, an orange color and a value 2 as emission strength. In a nutshell, this cube emits an orange light. Let's run the rendering again and see what information we are given in the input node regarding emission. Let's go back to compositing, select emit as the node to connect to the viewer, and we see that this is a color image in the meantime, and it shows us exclusively the light emitted by the cube because it is the only object frame that has a material that emits light. The next connector, NV, which stands for environment, shows us right now a completely black image because in the shot our environment, our sky, is not shown. So we could, for example, change the camera point. I duplicate the camera object to keep a copy of this shot. So we rotate the view, for example, in this direction, and with Ctrl-Alt-0 we go to set this new camera point. Let's also take a look at the environment setting in World in the shader editor. We see that it is a gray color, the classic default color. Let's go, for example, and add a sky texture and relaunch the rendering. We then go to look in compositing at the result, and we see that again it's a color image showing us the environment, so the light from our sky, from our sphere illuminating the scene. The next connector, AO, stands for ambient occlusion. This is a very interesting type of image in black and white and shows us the points where light is absorbed by the geometry of our objects. Let's look, for example, at the point where our vases are resting on the floor. You see that here the light bounces several times because there is a geometry that goes to touch with another geometry, and so by dint of bouncing it is gradually absorbed in each bounce, and this contact shadow is formed. This kind of shadow is called ambient occlusion, and it is due precisely to the geometry of our objects. In fact, we see even up here in this flap of the vase. At this point we have precisely an almost black image. This kind of image can be very useful to accentuate these kinds of shadows. We'll see maybe later on a practical example. Well, that's all for this lesson. As always, I thank you for following me. If you like, you have the possibility to download the handouts. You can find everything in the link that you find in the description to this video, and see you soon.